Lazy future.
It's a lazy future. You could call it a lazy future if you want.
But handle list triggers the execution of the task.
No. No, none of those. Like if you only the methods, like if I say call login and I will say unsafe, and all those methods will trigger the execution, unsafe ones. Anything else? So that's the trick here to understanding the rest of this workshop. Everything else is lazy. I'm just giving you yet another task. I'm slowly building this recipe. So fetch user was saying like, well, if somebody will call me, I will do this JDBC call. But then this, when we called map, that gave us another task that was like, okay, if somebody call me, what I will do is I will first call that fetch user guy. He will give me a user, and from that user, I will take the login. Then this guy handle with is another task who's saying like, okay, if actually I am being called with unsafe method, then I will call this guy underneath. If he throws an exception and that exception pattern matches, I will return that value. Otherwise, I will do whatever that guy is doing. So I'm slowly building this little recipe of things that will be done, but no calculations are yet triggered. So I could, given that this compiles, and it doesn't because yeah, you have to be, DB exception has to have this. And if I call it, nothing really will. Okay. Obviously, this has to be the return type of the pattern matching is task. So I have to close it. I have to close it within task. There are a few ways to do it, but if you want to close task over some value, you can just say point task, or if it's not point task, you can also say say task now, and that's pretty much it. And now this should compile. Come on, compiler. Oh yeah, because I'm not running it, I just okay. So let's say this is going to be our main method, and all that will be within that main method. So if I try to run it right now, it's running, but nothing happens. You don't see an exception. I can actually remove that. You know, I can throw another exception for you, like not the runtime exception, right? Blah. And if we run it, nothing will happen because what I got here, this login 2, is still just a recipe. It's still just a task of things that will be executed and evaluated if we run it. If I were to run it at some point, so if I say login 2 unsafe perform sync, come on, then this will obviously blow up right now because I'm throwing runtime exception, and there you go, you have runtime exception. All right, so I had a few exercises to like play with Scala, but could we just skip them so we can actually move on to other fun stuff? Makes sense? All right. As I said, if I had 8 hours, we could do Scala introduction as well, but we have only 6. Okay. Oh, and one. Jesus Christ, this is very important. I'm kind of a weirdo, so I tend to talk a lot, and kept forgetting that people actually need a break. So if you need a break, just yell, "We need a break," and then we make a break. All right. So whenever you need one, just let me know, and then don't be shy about it. If you need it right now, just let me know you need a break right now. So. Okay, so that's done. Now we're gonna move to something which is called type classes. So this is our like foundation for everything which we'll be covering further on from this workshop. Ability to understand what a type class is. Now, who doesn't know what a type class is? Awesome. So that's the part for you. So I will show you that with an example, and if you could please follow me in the workshop, that would be just awesome. But because especially the people who are struggling with what type class is, that code over here will not be needed for the next like parts of our workshop. So if you know what a type class is, just stay with me. You don't have to type it. But if it's new for you, then go with me. Okay. So let's say I have a function which we call it hello, and hello takes a user as an argument, right? And it will supposed to return as a string. So I want to say let's say hi and a user, right? This is my method here, and now I have a main method. So let's create a user, and that's going to be a user John the cameraman. And then I'm gonna call hello on it, right? So we can say like println hello, and we will say user. This is a wrong angle for people to type in. It's like, oh, my wrist is gonna be in pain. All right, so what will we get here? Any thoughts? If we actually run it, let me just
space user with the string.
Yeah. So if we run it, yeah. So it's supposed to be a new user. Sorry, new user. If we run it, we're gonna get hi, and so this is it, this part here. Oh, you guys don't see it, great, that's awesome. Let me do something about it. Yeah, I had the same issue 2 days ago, and we sort of deal with it in this way, which is a bit unfortunate, but so you guys see it? Like now? Should be fine, right? So we get hi, and this weirdness, like it's not really John the cameraman. It's just something. Oh, what is it? Well, the reason for it is that, well, in order for this thing to work in Scala, you would have to implement something which is called toString method. So if I say toString, and then I say that this returns a string, and I could just say, like, for example, first name plus last name or whatever, right? But the problem is, I want to have a type safety here. I would like to say, like here, I'm just saying user. The code compiles, even though I forgot to put the toString method to it, and that's not really what I want, because I'm just a human. I tend to forget stuff. I would rather like computer telling me, stupid human, you forgot to put that particular thing. What's worse is even like, so let's say I'm not that stupid and I will remember to put toString method to it, and I don't need compiler to it. But what happens if I say, well, hello will not work for users, it works for any type. For anything that is A, we just want to say hi A, right? And at this point, when we're writing this function, we kind of screwed, because we don't really know what A is, and we can only rely on JVM on the fact that all objects in Scala have toString method. So I can still, this thing will still compile, but now as the implementator of that method, I trust the caller of this method. Somebody who will call my method hello will remember to actually have a toString method within its type, which is not really what you want, right? There's no guarantees this will work. Like somebody might just pass some foo or bar without the string, and you will just get this weirdness. So we can actually do something about it. We could let's create trait, which will be called show, and it will be parameterized by some A. And then that show, we will define a method show, which will take something of type A as an argument, and will give us a string. And here we're just saying it's basically a trait. So it's like an interface, right? We're not providing any implementation for it. We're just saying if somebody has a type A, let's say a user, he might actually be able to provide an instance of that trait. So immediately we actually can do that for our user. So here we could just create an instance. So we could just say user show. It's really show of a user, and then we would say new show of type user, and then we need to implement that method def show. So we are saying whenever somebody gives us a user, we will just say we will say it's a user first name. I'm going to be using all the Scala tricks because that would be make things all more confusing, but just last name, and basically that's it, right? So now my method hello, I could actually say let's take this show as an argument. So I would just say it's a show of A. When you call my method hello, not only now you have to provide A, you also have to provide an instance of the trait show, right? For this to work, and then I can actually do sh show a. And so here in this example, when we're using hello, we have to provide this user show as a second argument. Okay, and here if we run it, if you call run with tilde up front, it will just keep on running, and whenever you do some changes and save those changes, it will recompile in one more time. So now I have hi John, right? Now I have all I needed, and the cool thing about it is now if I had some other class here like foo or whatever, and I would like to call hello with it, with hello with my foo instance, it's not enough. I'll still have to provide this thing for the whole thing to compile. So I have right now robustness, and I have assurance from the compiler, because he will yell, wait a minute, you didn't provide me that instance, what the hell, man, right? So now there's a neat trick from Scala, and I really cannot go into details. I just hope you guys, those who know the implicit will know, those who don't know implicit will suffer. But the idea here is I can say, when I'm defining this method, I can say, well, that parameter is in implicit scope, which means if I define it implicitly, I can say this implicit, then I don't really have to provide this. So what happens is Scala compiler will try to call our method here hello with just a user, and he will be like, wait a minute, I still need another argument. But wait, that argument is defined as implicit argument. So if there's something within the implicit scope that matches that type, and we have it, right, the user show, I'll be just fine. Okay? And just like short break here. Basically, what we just did, we defined a type class, and a type class is called show in our example. So if you want to think about what a type class is, basically type class, if you think about type as something like a set of values, right? Boolean is a set with two values, true and false. Integer is a set with values of all the integers that you can have, like within on your computer. Type class is a set of types. So when I define the type class show, I'm forming this little cool club VIP for all the types. You can join my club, my show club, as long as you implement this function show. So there'll be a user here, and like, can I join your club? And type class show will be like, okay, have you have an instance for trait show? I do. Then you're good. Then you're within my club. So any type can have a member within the type class as long as it provides the implementation for that method show. Okay, does it make sense? And now we have that type safety. But so as I said, type classes in languages like, for example, Haskell are built within the language. So this is a concept built within the language. In Scala, we didn't have type classes built within the language. We just had to rebuild them ourselves using machinery, which is within our language, which are implicits. Now, this looks still rather silly, and we could make it a little bit more beautiful. So what I could do is I could remove all that. Like I would just I would just keep copy of it so you guys actually see it for a minute, and I will remove it in a minute. So I could remove all that, and I could just say here, show. So this is like a little bit of syntactic sugar. This thing I'm just saying A. You can call A with any type. You can call hello with any type A as long as A is a member of type class show. Those two guys are exactly equivalent. The bytecode will be generated exactly the same thing. It's just like a little bit syntactic sugar, so you can reason better about your code. You're just saying, because there's a lot of boilerplate here happening, right? All those little craziness, I would like to show is just what I would like to tell as a implementer of this function hello. I just want to say, provide me A, but not any A. A is a member of type show. But so if I delete that, now I have a problem, because I just said A is a member of type class show, but how I actually can get instance of that show if I just deleted that argument, implicit argument. So what you could do, you can call implicitly implicitly and provide what you really need. So I need show of A, and that gives you that instance for you. And then you could call show on it with your argument, which is basically just killed the purpose, right? Doesn't make any sense. I mean, I've removed that from the type signature of the method, and it just moved to the method body. So fortunately, there are tricks we can do, and the first trick we can do. And as I said, this is a pain because you have to recreate all that what you normally in like a normal language would have up front built within the language. So I could say within show I can create a method apply. And now the thing is, whenever you have, this is like yet another Scala sugar, sorry. Whenever you have, I will just show you this, guys. So the apply method is parameterized by A. It's basically parameterized by A. And what we will be returning is we'll be returning show of A. This is what we're going to be returning. So in order for it to return, I'm just saying, A, we need to have an evidence that there is a type, the member of type class show for that A. And we were called implicitly here for show A, and this is what we're going to return. So now in our implementation we could just say show apply and provide our A. But the cool thing about and then we could just say, you know, here show and our A. But and this is yet another syntactic sugar in Scala. Whenever you're calling a method which is named apply, that's like a name reserved in the Scala language, you can just remove it. The compiler will know. Oh, if he's calling, so I will just say show for A, and now he knows basically that I'm doing this. Apply. He knows I want to do this, but I can remove it, and it's just basically nicer. So hopefully, it explodes. Obviously. Wait a minute. So couldn't find implicit value parameter. You couldn't? Yeah, because that's actually. Sorry. Now this will run. Okay, so now this compiles. So, and now you guys might be saying like, okay, so this still looks a little bit weird. Oh, I'm running out of time really, really fast. But do you guys get it? This part? Does that make sense? Who is lost? Like seriously, right now, who's lost? Okay, at which point? Okay, I'm losing people. All right, so there's one more trick we could do, and it's hopefully one last thing that actually requires Scala knowledge. Where's that? In which line? Well, yes, because if you let's try to remove that, right? So now if you remove it, you get an error, and the error will tell you, well, I couldn't find implicit value for parameter in type class show for your user here. I couldn't find implicit value for type show. So because this guy over here is your instance of that trait for show. No. It puts that value in implicit scope. So this still is telling you, this bit is telling you, A, there needs to be a show instance for A within implicit scope, and that is putting that into implicit scope. That's why it could be fine. This can be defined anywhere. You could define it here as well. You know, like as long as it's in the implicit scope and it's visible in that implicit scope, then we'll be able to fetch it. But that's a Scala thing. I do apologize for people who don't know Scala. I mean, but we have to really concentrate on people who do. So, just given the fact that we just lost one hour and a half. So the idea here is simple. We define a function. Hello for any A, but we're saying not any A. Yeah, I mean, this can be any type. I'm cool with it as long as you provide me, as you get an instance for that show trait for that A. If you have it, we're all good. And now I can reuse that instance. I can fetch that instance. So this is the trick I'm having to actually fetch that instance, and I can call the method that I need. And in this example, I need a method show to get a string for that A. And what's the value of it? Like that's the value. The value is pretty much still simple. Type safety. Now if I forget to actually if I forget to add toString to my class, nothing will happen. Compiler will be extremely happy about this fact, and it will just give you weird results. Here, if I forget to provide this and add it to implicit scope, compiler will tell me, well, sorry man, no can do. I don't have this. You have to provide me this in order to call that method. So type classes give you this ability to write a little bit more generic code. Because if you think about it, hello previously was only implemented for user, right? And defined only for user. Now I made it more generic. Now you can call hello with anybody. Like with anybody. And I'm just putting a little constraint on that anybody. Well, not really anybody. Everybody who is a member of type show. Does that make sense? Hopefully. Last trick, and I promise this is last Scala trick, but we will be using this, it's being used in Scala Z, that's why we have to understand it. So, okay. Alright, so if for you this still looks pretty ugly, some people would like to rather say, something like this. Instead of saying, so let me copy this for you. So some people would rather say something like that. Especially people who are come like a little bit from all over world of object oriented, they would rather say like, well, couldn't I just say a show? And give me like would be nice if I say like a is a member of type class show. So now magically give me a method show. So actually the method show underneath will call the member of that type class. And this is what we can actually do. So, and this requires something which is called implicit conversion. So we will create a new class which is called show ups. John, I have a question. Would it be okay if I just get some seed or something, because like I'm typing like this and I'm going to do that for 6 hours. No possible way. I'm gonna lose my wrist here. So I would say this is a class that takes something. So it's gonna be parameterized by a, and we will say that a needs to have a member of type show. All right. So far so good. And so we will have that a here. Okay. So it's just a class. Nothing scary so far. No magic. Stay with me. And then we will define a method show again. But this method doesn't take an argument. It's just a show. And it returns a string. Right? And what we will say that the body of this method is basically take show if instance for type A and call show on it with A. So that bit here, we just put what we had previously here before here. We put it here. Okay? Here. And now the craziness. So this will, oh, thank you very much. Cool. Okay. Oh no, because the projector crap. Will that work? You know, I will just do it during the break. I will do after lunch. If you want to know why object-oriented doesn't work, it doesn't work because it needs all those adapters. Fail. Okay. All right, we good. So now this thing, so check this out. I'm saying hi. I'm saying a show, and this will not compile. And the reason for that is that it's telling me value show is not a member of type A, because and it's a normal behavior from the compiler, right? A could be at this point anything. I mean, it's a member of type class show, all that, but it doesn't have a method show in it, right? Because we don't know really what A is at this point. So compiler is complaining, and we agree. You should complain. But now, if I do a little trick like this, so I will say this. I will import show like that. Compiler is happy suddenly for whatever reason. And the reason for that is there's a little bit of magic happening within the bytecode. So what compiler is doing right now, and this is last thing from the Scala language, I promise, called implicit conversion. So compiler says A, and we call show on it. He's just about to yell at us, stupid user, what the hell you doing? But he's realizing, wait a minute. Maybe, just maybe, there is a class within the implicit scope that wraps around this object, and that particular class has a method show on it. Is there one? Whoa, there is, right? Awesome. So what compiler will do underneath for us, this is what basically compiler will do. It will, if he sees something like that, he will create a new instance of showops, wraps over our A, and call that show method on it. So this show method, right, this one, is that show method. This one. So it's this magic over here between those two lines is done by the compiler for us. And the reason for that, we imported everything defined within show. So we imported also this implicit class, and he can basically find it. That's why he has this ability to call show on value A. Last thing from Scala, I promise, but does it make sense? This compiler is doing a little bit of magic for us. I'm not particular fan of magic in programming languages, but since Scala doesn't have type classes, it's a little bit of magic that we actually need. Not the magic we deserve. All right. So now we have everything. We just created a type class. Any questions about type classes so far? We'll be using a lot of type classes, so if some things are not yet in your brains like correctly, no worries, we will see all that in a minute. So if you guys all good, I have we can do like we're gonna have lunch. Are you able to survive for the next 30 minutes, or you have to have a break? Seriously, like thumbs up, like thumbs down, thumbs down.
For what?
We're good. All right, so exercise for you. It's under the same folder, and it's called exercise. And the idea here is to implement a type class called equals, and equals will be parameterized by A. So equals will have a method eq, which is equal, right? And it takes us as an arguments two A's, A1 and A2, and returns a Boolean value whether A1 is equal to A2. If they are equal, then you give it true. If they're not, you give it false. So write a type class for any A equals. Then once you have that, create the equals option and equals companion object with that apply method. So everything that we did here so far, hope you guys were following, just redo the same thing, but for equals type class. Once you have it, you can create two instances, for example, one for string and one for user. And if somebody will do it really, really quickly, there's like an extra exercise. The last one, which is let's say I have a type class for type A, instance for equals for A, and I have a instance for equals for B. Could I automatically create equals type class for a tuple AB? And the answer is yes, and you can just pretty much implement it if you have time.
Could you get your show code up, or would that be cheating?
That will be a bit of cheating, but there you go. You are supposed to follow.
I was following, I didn't type it.
Okay. So there's the show. I know those exercises take time, but the reason we will do them is that if you look at the conference presentation, all that, you might think you understand everything, but once you actually have to type that in, and the compiler is complaining all the time, that's when the learning moment happens, and that's why we need to do this. Okay, so the way you do it is you provide here your main method, which, or the way, okay, so the easiest way to do it actually would be to go here to the exercise, right here, and just say extends app. But that has sometimes some issues within Scala. So what I tend to do is I just create a main method which looks like this. And then everything you put into that main method, if you call sbt run, it will run it. It will run it. Yep.
Can you show us the signature for the main method again?
Oh, sure. Sorry. Now the thing about type classes is that they also sometimes come with a law. So there's not only a function that the type has to implement, but there are also some laws which tell you how that function should behave. Within show, we don't really have those laws, but we're going to see in a moment type classes which actually have to obey a law. So if you provide an instance for a type class, not only that has to compile, but there are some additional checks that they need to be run through so that we know that it actually compiles. So one of the laws you can think about is like, well, I just forgot the English word for it. It will come back, no worries. Crap. I'm getting old. Anyways.
Say the word in your language.
Yeah, it's pretty much similar to the English one and Polish one. I just forgot the word. But I'll be there in a minute. Just
You know, there's a little EQ with object or logic. And there's a name class.
there's EQ. Okay, there might be a. So just change the name EQ to something like EQ, new EQ or whatever, right? Because apparently there's a name okay, EQ2 or whatever. There's a name class apparently with Scala code base.
Implicitly a Scala Z thing.
No, implicit and implicitly it's Scala thing.
The implicitly, that's a Scala core thing as well.
Where was that? Who's asking?
Implicitly.
Implicit and implicitly are from Scala language. But implicitly is being, so that this pattern of using implicitly and doing this apply method is basically what Scala Z is doing all the time. It's just a nice pattern to have. That's what I'm showing you guys, this pattern.
There has been no Scala Z in this type of example, right? There has been no Scala Z at all in this type of example.
There's been no what?
Have we used any amount of Scala Z?
No, not at all. Like if you look at the imports, no Scala Z here at this point. Like empty. So far we are surviving without the library. So the first 2 points from the exercise are already on the screen. If you're lost. So sometimes when you're creating a new type class, so for example, in the point number 3 is to create an instance for both string and user. So what sometimes happens, if you create your own library and you create your own type class for your library, you put into the companion object instances for like typical types. So like you want to create one for string, which will be available if you actually import it. So if somebody will be calling your function externally for their own data structures, like user, for example, they will have to provide that instance. But you don't want them to provide instance for string every time they use your library, right? That's why you, for example, you will provide an implicit instance for example, for string in the companion object. Well. Okay, so really quickly, I hope you who struggled with the exercise. I'm not saying it has to be done, but struggle. So this is basically what we've doing before. We have up there we have a trait which was equals a2 and 2, which is supposed to give us a boolean. One more time we have an apply class, so then we will be able to use this little trick to actually get an instance of for that equals type class for a given type. One more time we have an ops class. This time it still has to it still has to wrap over a single argument, so it wraps over first a, and then our equal method takes the second argument as parameter, and we can take the instance of the type class equals for that any type, whatever that is, and call equal on A and on A2. Now, so as I said, you can provide instances for types which are, for example, in standard library in the in the companion object, so they can be reused for your users. They don't have to provide each time they use your function with string. They don't have to provide that instance for string because, well, pretty obvious. It's just a straightforward implementation. Now here I've created an instance for user class for equals, and check this out. We could do two things. We could just say, you know, we're gonna take user 1 and user 2, and they only are equal if login is equal to login, and we are here one more time using this this equal sign. But we could also take advantage of the fact that we already have an instance of equals type class for string, and logins are string. So we could just say this. It will import the instance for string, and we will just say user 1 login equal user 2 login. Okay, and the last question would be, did anybody did the last exercise, the number 4? Okay, and what did you do?
Define an implicit method that combines the other two
Yeah.
type classes.
Yeah, because basically what we need we need implicit for, yeah, I don't know how to type. We need implicit for tuple equals, which basically we need. So we might say there's a def, and it will be parameterized by a and b, and we will say, so we will give you a equals type class for a tuple a and b. We will give you that, right? But only if actually a has a type class of equals, and the same goes for b. And then if we're creating instance of the type class, we would just reuse a method equals for a, for b as well. If they, and simple logic, true and true gives us true. Anything else is false, right?
Is there a reason you made a method out of the tuple one and not the other?
Because the reason for that is I don't know what a and b will be, so I had to parameterize. Previously, I was creating type for string, right? I already know what string is as a concrete type. Here I'm saying I want to create an instance for any tuple, not tuple, string, and integer, for any tuple. That's why I need to say, that's why I need a method to be able to provide polymorphism into my solution. So I'm just saying a and b, not any a, not any b, but a and b that actually are members of equals. Can we move on? Like, who's completely lost at this point? Because I don't want to lose you right now. Because otherwise it's going to be like a waste of your time for the next 4 hours.
Well, I just don't understand what you're asking to do for the tuple. What was the
Let's just implement it till the very end. All right. So equals. Come on, equals. And we want to have equals for tuple of a and b. Right. So we want to have this, and we want to have functional equal to that will take two things as arguments. So the first one will be tuple 1, so it's actually tuple of a and b, right? And the second one will tuple of also of a and b, right? Right?
Comparing two tuples, not.
I'm comparing two tuples of type n and b, any two tuples right now. So now if I build, okay, so let's just finish this exercise, and so now I can call. So I will just say take the T1 first element, from T1, and I will call equals on it with second tuple first element, right? And then I will say, simple logic, right? And I will do the same thing, but for B. Right, so for B will be, this is taking B, right? This is taking like a second element from tuple, right? So now if I have this, then basically, in order for this to actually work, we need that import. Oh, it's already in scope. So now if I have instance for both string and a user, right? and let's say I have a tuple, weirdo, that is basically a tuple of string and a user. This is my tuple, right? It's going to be like, blah and user blah, and I have two of those. The first one and the second one. Right? Let's make them a little bit different, like that, right? So now I could actually call weird one equals to weird two, and I don't have to provide anything else. I don't have to create an instance of a type class for a tuple because I just created a generic one, and that's the beauty of it. If you have a type class for some basic types, then you can construct types for more complex structures, like for example tuples or any ADTs that you have, and it will just basically work. I don't need to provide yet additional instance of a type class. You do it once. Actually, basically most of the time the library implementator does it for you, and then you just reuse it wherever it exists. Okay, 10 minutes till lunch. So I'm just wondering, should we continue? Probably yes. But I want to take this time so this is our foundation at this point. Well, Scala was supposed to be something you guys already know. Type classes are foundation to understand everything else. So are there any questions towards what we are doing right now? You're sure?
Can we run some of that bottom block?
Was that?
Can we run some of that bottom block?
Sure. Does it compile?
We expect that to return false, right?
It first has to compile. So I need to import. I will just import this. Okay. So yeah, it's not weird, it's weird. Okay. Yeah. Okay. So now it compiles. So now I call it, right? So I want to say whether this is true or false, right? So println. There you go. And you got false here. If you don't see it, give me a second. So here. There we go, false. But if we so let's say those two guys are going to be exactly the same, right? Then hopefully it's true. Works? Okay. All right, 7 minutes till lunch. So we will start with new stuff. That'll be a good time for having lunch right now. That will be a good break. I could dance for you, but I don't know how. Let's just go with the next. So the next step is going to be something which is called Toolbox, and it would be really nice if you guys could follow typing all that with me. And it will really help understanding what we're actually doing and what kind of problems we're going to have. So in this section we're going to learn all those weird different names like, yes?
Are you going to be submitting the code that you're picking?
I can. Okay, so I will, after lunch, I will commit all that code to a separate branch. Is that okay? Awesome. So now we're going to learn all those different weird names that you will normally hear on the functional programming conference. If you're new to LambdaConf, majority of you guys probably are only here to finally understand the monad, right? We will eventually get there, but I don't want to give you just definitions because that would be plain stupid. So what we will do is we will slowly build little problems that we will try to solve, and then we will pick from Scala, that from the toolbox of FP paradigm, existing tools that actually allows us to fix those problems, those issues that we have. And now the only weirdness about FP is that they sound weird. It would be like applicative. That's just a weird name if you were sleeping through the whole math class on universities. But beside that, it's basically pretty straightforward concept. Now, I deliberately didn't choose examples which are complex. At the beginning, I thought like, oh, I will just choose some examples like a little bit to the real world, which I did on winter retreat a few months ago, and that failed because people were more focusing on the example itself than actually on the problem. They had to struggle with understanding the example and then understanding the applicatives and applies and all that. So what we will be doing, we'll be dealing with functions like length or plus, to adding two integers together. And on those examples, we will be having some problems and we will be trying to solve those problems. But I'm just saying, don't think that functional programming solves only those little issues. I'm choosing those simple problems because I don't want you guys, I just want to use examples which you guys already understand, because hopefully everybody knows how to add two integers together, right? That's hopefully our basis here. So that's the basis, so we can actually reason about only FP paradigms, not on the examples themselves. I don't want to do that mistake I did the last time. So as I said, let's create a simple function which we're gonna call length, and length takes a string and gives us integer. So that's really hard, right? That's really whoa. So we'll just say length. That's really what it is. Okay. And now let's say we have a function that we will call length operation. And this is my method, not function. This is a method that takes a string and was supposed to give us that integer. So obviously we can just call length on it, right, with string, and this will work, right? Makes sense? No magic whatsoever. Now, so let's actually create a main method and create some string. And I know there's lunch in 4 minutes, so I would only just start and I will just create a problem, and after lunch we will try to solve it. So I have a string. Now I can obviously call my length operation with that string, right? And I'll be fine. This hopefully compiles. I have to kill the main method in exercise, so I will just call it main. So I'll be committing that code, but the mains will be just like something like that, so we don't get actually the conflict. Okay. So now this code compiles. I could actually print it out if I wanted to, but we sort of think that we see that it works. And what happens is actually somebody will say like, oh, you know what? The requirements actually changed. We don't longer have string. What we have is an option of string. Right? That sucks. Right? What we have is this. Well, this will obviously not compile. So we will do what we normally would do. We just work around the problem, and we will say like, okay, so we will take an option of string, and we will return you an option of int. And now, okay, so now this will not compile obviously, but the nice thing about option is it has a method which is called map. So you can call on option, you can call map, and the map will take a lambda as parameter. So if the value exists within the option, it will be an argument to that function. So we could just say well, there is some string, and just call length with that string. Or, which is even better, because it actually needs a lambda and we already have that lambda, so we can just say length. So far so good? Right? 3 minutes, I know. I'm aware of the lunch, so don't worry. But then again, the requirement changed, because why not, right? And they say like, oh, actually, you know what? That string, we actually fetch this from database. So maybe now it's not an option. It's let's say it's an either type. So either like option was not enough, right? So now we want to know what the error was. So it's actually throwable or string. So we can say right here. And now again, okay, we can change the signature of method, which is sort of troublesome. We can do it, and so yeah. So just let's. So we will say it will take either type of throwable or string, and one more time it would just returns this a throwable or int. And as it turns out, the implementation is exactly the same, because either type also has a math method, right? But now, so the requirements is that let's stick with either type. But then somebody comes in and say like, no, not really, man. Actually, that value comes from database. So now it's a task of string. Now this is just becoming ridiculous at this point, right? Because like how many times you can actually say hello in different, with different types, like closing that hello or different stuff. So yeah, one more time I can just say, holy crap! Okay, this is a task of string. God damn it! And I will return you a task of int. Can I go home now? And map works. But then you realize before you're gonna go home, realize this can go on forever, right? They can just bring you types every other day. So now you try to figure out, like, could I actually say something different? I always have some f, which basically has a hole. There's a type constructor, and my string is closed over that f. I don't know what that f is, but I will return you an f of int. I don't know yet how I'm going to implement this method, but it would be nice if I had something like that, right? Instead of saying for each of the operations, it's an option for either, for task, for whatever, I'll just say, you choose. And that's the beauty about functional programming, because we have this inversion of control. Instead of them giving me Jira task, could it now be a different type? I'll just saying, your call, man. I will do whatever you want me to do, but that the type, you define the type that's gonna for the input type and for the output type as well. It would be really nice if we could just implement it this way, right? Have our call a little bit more abstract. Instead of saying a task or option or either, we're just saying anything. I know it's luncheon. I know. Yeah, so let's go eat.